Hi students, these notes are about Chapter 15, Section 3, which is about atmospheric pressure and winds. So, you might be wondering what wind is. Well, wind is just another name for moving air, right? You've noticed it on a lot of spring days or any time of year that wind moves from one place to another, and that wind is caused by or is created by differences in air pressure. We talked in units past about how air pressure is the force of air pushing down. And when two areas have a different amount of air pressure, air is going to rush from areas of high pressure to low pressure. The greater the difference between those two areas, the stronger the wind will be. So if we have an area of really low air pressure, air molecules will want to move into that space really quickly, which will make a stronger wind current. At the equator, you can assume that because the equator is more directly in line with the sun, the air at the equator is warm. When air molecules are warm, they spread out, so the air is less dense. And when air is less dense, it is low pressure, right? If low pressure, or if air pressure is caused by the force of air pushing down, when we have molecules that are really spread out, there's not that much force pushing down. As opposed to air at the poles, it's cold air, it's more dense because of the way the air molecules move when they have less thermal energy, and it's high pressure. It's high pressure because in this same amount of area, there would be a lot more air molecules crammed inside the same amount of space. So when there's more air molecules stuffed inside, that means that they have more weight or more mass in the same area, which will lead to a lot more pressure in the same amount of area. So cold air, high pressure, warm air, low pressure. A low pressure zone, generally where it's warm, like at the equators, is where warm air is rising, right? If warm air is rising up, it will be pushing down very gently, if at all, on the earth below. And if it's a high pressure zone, like at the poles, the North Pole and the South Pole, where it's very cold, cold air will be sinking and applying a lot more pressure down onto the ground. Surface winds are winds that blow across the surface of the earth, and they're going to blow generally from the poles to the equator. When that happens, the warm air at the equator rises up because it's less dense. When it leaves space for the cold, dense air, after it's floated up from the earth, it leaves space for cold, dense air to enter from the poles. Air from the poles is cold. It has fallen or sank down to the ground and is dense. So let's look at this picture down here. So surface winds are going to happen because we have an area of low pressure right here. Low pressure means warm. Warm air is less dense. Less dense air rises. So here we have air that's going to float up away from Earth's surface. Once this happens, then there's going to be, for just a moment, an area of empty space. Empty space where that warm air just rose up from Earth's surface. Well, nature doesn't really like an empty space, so what's going to happen is that cold air that's blowing from across the Earth's surface is going to fill in that space. So if we have an area of high pressure, like at the poles where it's cold, air is sinking down, and the air that has sunk down will blow across the surface of the earth until it finds that empty space. Right? Air molecules want to spread out as much as they can. If there's a big empty space left by warm rising air, the air molecules will rush in to fill that empty space. This caption kind of dictates that again. In a low pressure zone, warm air becomes less dense and rises. In a high pressure zone, cold air condenses and sinks to the ground. So just as a reminder, cold air equals high pressure. Warm air equals low pressure. So you may be wondering, where does this process happen, or how does this process happen more specifically? So pressure belts are a name for where these cycles of warm rising air and cold sinking air happen. So pressure belts, it's not one huge circular pattern over across the whole of the Earth, but there are many smaller patterns called convection cells. And I'm going to show you over here in just a second about all the different convection cells that are on Earth. But a convection cell, and we've talked about this before when we learned about how energy is transferred through convected air. But a convection cell is a circular pattern caused by rising of warm air and sinking of cooler air. How it works. So warm air, maybe we'll look at this picture to kind of illustrate it. Warm air around the equator, so that's right over here. Warm air around the equator rises up away from Earth's surface, because it's less dense. As it rises, it's getting further away from the ground that made it warm. So as it rises, it cools and is going to start to move towards the poles. And this will happen, it might flow north towards the North Pole, or air at the equator might start to flow south towards the South Pole. So here we have it again. Warm air around the equator rises because it's warm and therefore less dense. As it rises, it cools and it starts to move towards the poles. It moves away from the equator towards the cooler places. It continues cooling as it moves away from the equator until it becomes so dense, so cold and so dense that it falls back down towards the Earth. Falls back down towards the Earth. In any high pressure zone. This wind then travels along the Earth and warms up as it reapproaches the equator and restarting the cycle. So now we have air that's further away from the equator moving back towards the equator, because this cycle is happening continuously on and on and on. So as more air leaves and floats up from the equator, that's always making new space for cooler air to flow in from the poles or from south of the equator or north of the equator, because this air isn't coming all the way from the poles. That's not true. It's just happening in this little convection cell. Blows in across the surface of the Earth towards the equator, and these cycles happen at about every 30 degrees of latitude. So you know a little bit about spheres, that from this pole to this pole, halfway across the Earth, that's 180 degrees. 180 divided by every 30 degrees of latitude means that there are 6 pressure belts. And they kind of span across around the whole globe. So there's 1, 2, 3, 4, 5, and you can't really see the last one because of the way the Earth is tilted in this picture, but 6. 6 pressure belts. And that's where we have general trends of wind flowing across the Earth. And I'm going to erase this all again so you can see me drawing. It's flowing across the surface of the Earth towards warmer areas. It floats up from the warmest area in the pressure belt. Then it will flow away from the Earth, higher in the atmosphere, towards the colder area, and then the cycle restarts again. So up at the equator, away from the equator in the atmosphere, back towards the equator on the surface of the Earth. right? The Coriolis effect is the effect of the rotation of the Earth. Because the Earth spins, it causes winds to curve. And you know that winds move because if you've ever gone on a long flight east to west, maybe you've been to Europe or maybe you've been to California, you know that the wind, as the Earth spins, is moving with the Earth. That's why it takes a little bit longer to go west. So if you're traveling from Boston to California, that flight would take a little bit longer than if you were going from California to Boston, just because of the way the wind is moving. So because the Earth is spinning and rotating, that means that the air is moving faster at the equator, where it has a long distance to go, and not quite as fast at the poles because it has a shorter distance to go, and this causes winds to curve. We will talk more about this in a later unit. Alright, finally, there's different types of winds. Global winds, like I was talking about before with the different convection cells or pressure belts, global winds are a pattern of air circulating that moves across much of the Earth, right? Like 30 degrees of latitude is a pretty significant distance across the Earth. So those are global winds, the way air generally moves from the poles towards the equator. Global winds, long distance. In contrast to that, we have local winds. Local winds generally move short distances and can blow from any direction. They're still caused by uneven heating and cooling of air, but they're influenced by geography and topography, most specifically shorelines and hills or valleys. So you'll notice down here there's two specific, these are types of local winds, and they're named after where they blow from. So an ocean local wind is air that comes from the ocean. A mountain local wind is air that comes from the mountain. A valley local wind is air that comes from the valley or the bottom of the mountain. So in an ocean, you might know this if you've ever been to the beach on a hot day, the sand or the land heats up much faster than the water, so that would mean a high pressure area above the sand, and the water stays pretty cool, so there's a low pressure area above the water. So what happens is we have land heating up fast, and that makes a high pressure zone. So a lot of times if you're sitting on the beach, you'll notice on a hot day that the wind feels like it's always rushing towards you. So the fact that the land and the water heat and cool differently, that makes makes for uneven pressure, makes for winds. And a mountain local wind or a valley local wind, warm air from the valley causes a valley breeze during the day, so warm air is rising up the mountain from the valley, so we call that a valley wind. At night, cold air sinks into the valley from the mountaintop, so we call that a mountain wind because it's blowing from the mountain down into the valley.